You are tasked with drinking a mole of water molecules right now. Not a glass, not a gallon, a mole. In chemistry, this is a fundamental unit of measurement. Most people hear that word and imagine a cosmic quantity of liquid. They are correct. The number is Avogadro's constant, 6.022 times 10 to the 23rd power. That is a 6 followed by 23 zeros. It is a number so large it defies human intuition. If you tried to count these molecules one by one, the universe would end before you finish the first percent. The sheer scale suggests a flood that could drown entire solar systems in an instant. To visualize this scale, imagine every water molecule is a single grain of sand. A mole of sand would cover the entire Earth in a layer several feet deep. It would bury every skyscraper and fill every valley. You are not just drinking a glass of water. You are drinking a geological event. The pressure of this much liquid should, theoretically, crush your internal organs into a dense, watery paste. Your stomach would expand with the force of 1,000 collapsing stars. The physics of such a volume would warp the local gravity of your living room. You are facing a hydration event of apocalyptic proportions. This is the terror of the molar scale. Then, the math happens. Water has a molar mass of 18.015 grams. 1 mole of water molecules weighs exactly 18 grams. That is roughly 18 milliliters. In practical terms, you are drinking about 1 single tablespoon of water. It is barely a sip. The disappointment is immediate. Your body does not warp. Gravity remains stable. Your kidneys do not even notice the arrival of the 18 milliliters. The biological impact is negligible. You have consumed a fundamental constant of the universe, and the result is a slightly damp tongue. This is the great deception of chemistry. The numbers are astronomical, but the actual mass is trivial. The terrifying mole is just a tiny puddle. However, the danger is not the water. The danger is the curiosity. You now realize that the mole is the unit. You wonder what happens if you apply this same unit to something less friendly. You decide to drink a mole of something else. Specifically, you choose a mole of pure elemental sodium. This is where the real physics begin. This is where the situation becomes interesting. A mole of sodium weighs 22.99 grams. This is roughly the size of a small walnut. You swallow the metal. The moment the sodium hits the moisture in your throat, the chemical reaction triggers. Sodium reacts violently with water to produce sodium hydroxide and hydrogen gas. This is not a slow burn. It is an immediate exothermic eruption. The reaction releases a massive amount of heat, instantly boiling the saliva in your mouth. Hydrogen gas expands rapidly, creating a high-pressure bubble inside your esophagus. The heat turns the surrounding tissue into charred carbon. Your throat becomes a combustion chamber. The gas has nowhere to go, so it forces its way upward and downward simultaneously. The chemical burn is caustic, dissolving the lining of your stomach on contact. You are no longer a human being. You are a biological pressure vessel filled with a caustic, boiling alkali solution. The internal pressure reaches a critical threshold. The structural integrity of your torso fails. The hydrogen gas ignites from the heat of the reaction. A localized explosion rips through your chest cavity. The blast wave shatters your ribs and sends fragments of bone flying like shrapnel through the room. Your skin cannot contain the expanding plasma. A flash of blinding white light consumes your torso, turning your internal organs into a fine, ionized mist. The shock wave blows out every window in the house. The surrounding air is superheated, causing the wallpaper to spontaneously combust. The remnants of your body are propelled backward, leaving a scorched silhouette on the wall. The sodium has successfully completed its reaction. The resulting sodium hydroxide is now smeared across your furniture, eating through the fabric and the floorboards. The house begins to smell like burnt hair and industrial bleach. This is the physical reality of molar quantities when the element is not hydrogen and oxygen. The energy release is clean, efficient, and completely devastating. You have successfully transitioned from a slightly hydrated person to a cloud of expanding gas and caustic salts. The room is now a hazardous waste site. The explosion was spectacular. The physics were absolute. The chemical energy of 23 grams of sodium turned you into a human firework. In the end, the difference between a refreshing sip of water and a lethal explosion was simply the arrangement of the atoms. 1 mole of water is a snack. 1 mole of sodium is a demolition charge. The scale of the number remains the same, but the results are fundamentally different. As the smoke clears, a representative from your homeowner's insurance arrives. He looks at the blackened crater where you once stood. He sighs and informs you that chemical explosions caused by curiosity are explicitly excluded from your policy. You are now liable for the damages. Curiosity is expensive. Next time, stick to the water. Subscribe to the What If Club to see more ways to accidentally vaporize yourself. We have plenty of ideas.